derivative rule.
Hello. Okay, so part of the derivative of e to the x is really easy. If you guys take the derivative of e to the x, it just stays e to the x. The derivative is itself, which is really nice. But it gets a little bit more complicated if you guys have something besides just x there. If we have e to the x plus 3 or e to the x squared, what we have to do is apply this part of the rule. And all this stuff is on your green sheet too, but
The blue one or
oh, sorry, your blue one. Thanks, Ryan. But again, sometimes when you see them, it just looks kind of weird. So what we're going to do is make u be the exponent, but when you guys take the derivative, it's going to be e to the u. This is the part that's a little tricky. It's du over dx. Right? So this part right here is going to be a little bit different for us.
yeah, good thing is the derivative of u.
Yeah. We have to like actually find this. Alright, so once you guys see an example, I don't think it'll be as bad, but it's hard to, if you were just going to like look in the book and figure it out. Okay, so here's your example 1. So if I have, for all of these, we're going to find dy dx. Right, so we're going to take the derivative of all this stuff. So here's my first example. Y equals e to the negative 5x dx. If you're someone who's not careful with your notation, like you forget to write like d's or x's after things, this is going to be tricky because you're not going to see what you have to divide by. Well, you do a really good job with your notation. Like you always have like everything laid out really nice. So just make sure you guys are. Oh, look at you. You'll say. All right. So let's figure out, what do you guys want to let u be?
5 negative.
Negative 5x. Good. Okay. Good.
So u equals dx.
Okay, now du, be really careful of this. Du is going to be what? Negative 5. Now, here's the tricky part. You have to make sure this part of your notation is really careful. What did you take the derivative with respect to?
dx.
X. Okay, so negative 5 dx. That's what du equals. Now, what you guys want to find is this, du over dx. So imagine, what would you have to divide this by? Dx. Nice, Kaylee. Okay, so if I divide by dx, okay, so du over dx is equal to negative 5. And that's kind of a step we have not done ever to get that du over dx. Right, but usually, okay, here's what originally, like, I didn't want you guys to get confused with. You guys are so used to like matching things with integration that you make like a fraction of like negative 1/5. But we have to be careful we're not doing that because we don't want just dx over here. You want a du over dx. You really have to take that extra step to like find it. You know, you're not really making like a correction this time. It's more like a solving. You're like subbing it back in. A little tricky. Right. Once you guys have all this stuff done, and once you get good at it, I mean, you guys can kind of go a little faster. But now we take this property, our e to the u, well, we have e, so y prime equals e to the u, which was just negative 5x, times, right, du dx was negative 5, so times negative 5. Now to clean this up, y prime equals, put this part in front, so negative 5 e to the negative 5x. And that would be your final answer. What? They get a little harder, but this is like the gist. The tougher part is like, if you look in your textbook, it's kind of figure out this, because they don't ever tell you any of this stuff. They don't like go through nicely to like step it out what you're supposed to do. So, you know, if you were just kind of looking through your textbook, I think it's a little tricky. But, yeah, but this part is the big one. Let's try another one. Okay. So again, we don't have just like a nice e to the x. We can't make it itself, but we have to use our u's. So u would equal negative x squared. Du is going to be negative 2x. Good, and make sure you guys write your dx. Alright, now we have to get du over dx. Okay. So divide by dx, just like last time. And so now we have what you need. You have that du over dx. And when you guys put it all together, we're going to have e to the u, which is negative x squared, times du dx, which is negative 2x. And then we just have to put it all together. Negative 2x to e negative x squared. Which one is dx? Yeah, just multiplying, exactly. So usually put out in front. Let's put it instead. What do you guys think so far? Are we okay with figuring out the du over dx? That's the tough part. The negative 3 over x squared. Okay. A little bit tougher here. Figure out what your u is, your du, and all that good stuff. To make your life a little bit easier, what did you guys do with that x squared? Bring it to the top, Courtney. Oh, good job. Right. Yeah, bring it up, and then just make sure you remember to switch your sign. It'll make it much easier. Negative 3x to the negative 2. Yep, good. So when you do your du, would you say what's 6x to the negative 3? This is your u. Yeah, just read it, because did you do any derivative?
Oh, okay,
Good. Before you bring the x down, make sure you guys get du over dx, divide by dx. That's looking good. We have our du over dx, which is what you want. Let you guys kind of keep going from here. I would make sure you guys have all positive exponents again.
Yeah.
You're not going to be Friday?
Why?
Who has like community work? Well, it's a plan. Well,
Here, let's finish this and we talk about I know, she's excited. Alright, so you guys have e to the negative 3 over x squared times 6x to the negative 3. Hopefully when you guys put it out. Now, just watch when you guys simplify things. Is this negative 3 connected with a 6? Or just the x? Just the x, good. So when you guys move everything, this is going to have to go down. And this whole thing has a negative exponent, so that's going to go down too. Okay, so your final answer would actually be this. If you did e to the 3 over x squared and then times x cubed, that means the same thing. Because when you do your original, like e to the u, your u is a negative exponent, right? So you don't want to leave it usually with a negative exponent. You'll bring it back down.
Isn't 3 over x squared?
Like, maybe I should have, this would help you if I did that. Okay, like so, sorry, the negative like belongs to like the whole, like out, imagine like out in front, sorry.
No, you're fine. I don't know why I couldn't.
That's okay.
I was thinking of the x squared, exponent of the x squared, and all of it.
Yeah, there's just like the top part.
Yeah.
Alright, so sometimes you guys could see other things that involve e to the x, like this one. It's a teeny different. What do you think you're going to have to do here? You think you're doing derivative? Product rule. Yes, Aaron. Okay. So some of this comes back. Okay. So when you guys do your product rule, same exact thing, except now we know that the derivative of e to the x is just e to the x. So it's kind of nice. All right. Well, when you guys put, if you don't have to product rule, remember, feel free. Okay. So we take u prime. Okay, b stays the same plus x. Well, even if we take the derivative of e to the x, it's still e to the x. Okay. Product rule. Yeah, you got it, Kyle. I like it. GCL.
Okay, I don't know the steps.
I know.
I'll just look at the video later.
It's just the derivative part of the rule. It's not bad. And just, yeah. We should have y prime. That's it. Yep.
What happened to the whole?
Yeah, what happened to the
Because the e to the x is just what?
yeah. So, yeah, look at, okay, so you have,
Oh, word?
so here's your two rules, right? If you just have e to the x and there's just x up there, the derivative is just e to the x. It's nice, but so we don't have to like,
Because you already took the derivative, the product rule is taking the derivative, is that what that means?
yeah, product rule is like part of a derivative when you're multiplying a function.
So you don't need to divide like by dx or anything?
Nope, because Sarah, what you could do, I mean, it would be making it it'd be making it more difficult. You don't have to do it. But if you, let's say you wanted to do it like what we were doing before, okay? If you were just going to take the derivative of e to the x, okay, so here we go. So if you were going to use this, and let's say you let u equal x, okay? What's du? 1 dx. Now, if you divide it by dx, you would just be multiplying it by 1. So what you would be getting is e to the x times 1, which is just, so see how it's the same?
Yeah.
Okay.
So you multiply your derivative times what you get from that.
It's e to the u times du over dx. So it's like this part's different, Kyle. You have to do a little, it's like you have to divide by dx to get du over dx, and that's what this is. Okay. And then it's e to the u times e to the x. That's like what your derivative rule is. Sarah, you'll like this one. I think will make it a little bit. Okay. Try this one.
Yeah, so oh my god, 2x, so 2x e to the negative x plus x squared negative e to the x. E squared.
Hey, me no
What's the word any louder? Sorry. 2x e to the negative x.
Sean?
I make a point there.
If you guys, you just, with this one, when it's not e to the x, if it helps you, let this, do it like we were doing before, let it du, find your du over dx.
So you don't use product rule here?
Negative.
Yeah, you do.
You gotta use product rule?
Yep, use product rule.
Steps though, you have to do the other step first, right?
I mean, you don't have to, you can do it as you go.
But it doesn't hurt you.
So, negative 1 to 0.
Yep. That's like your opinion part. That's like, Kelly, you're thinking like -1 is your du over x, yeah.
Yeah. So like I use that in my product rule with my v prime.
Yeah, exactly.
So one of your use a negative amount plus +1 and minus b cancel out.
No, this.
So I have a question.
It's not
Great. I'm taking that negative out.
Oh wait, no. You just got it wrong. Why would you take it off?
Let's finish that negative.
It would be a half.
This right?
Why?
From that part. Alright, let's see what we got going on here. When you guys get your u prime, right, so we get 2x. Yeah. Okay. Now, then your v stays the same. Plus, right, we get x squared. Now this part may give you guys some trouble. Right, if you needed to go on the side of your paper, figure out what your u is. Your du is -1 dx. Okay. Okay. So now this whole thing, when you guys take the derivative, it's like saying -1 e to the negative x. Okay.
Why do you need that? You need the negative x.
Well, that's what your derivative is of e to the x. You can't just like.
I just put -1.
Yeah, because you have to take the derivative of this whole thing. You just kind of like left out the e to the x part. Like, you have to do this whole process just for this little piece. You have to figure out what the derivative of e to the negative x is.
So then why do you put e to the negative x after -1?
Okay, because when you take the derivative of e to the u, it's e to the u du dx. So you need to write, here's your du dx,
Oh, okay.
and here's your e to the u
I
part.
forgot that step.
Yep.
Thank you.
You're welcome. Watch out for your negative here, guys. 2x e to the negative x minus x squared e to the negative x. Your book does a lot of factoring out things. Now, if you move stuff down, you factored it out, you should be getting the same stuff. If you factor things out, we have a GCF of e to the negative x and then an x. So it would be 2 minus x. Right? If you wanted to keep going and maybe you wanted to bring this down below, you could do that too. Right? But you change your exponent to be positive.
Do we have to bring the negative or the exponent down?
Look and see how your book reads it.
Okay, because like in example 3, you said you have to bring it down, but like in example 1 and 2, we didn't bring it down, so I'm not. I don't think we brought it down yet, no. We just left it, so I didn't know if we
Oh,
had
yeah,
to.
okay. I mean, you're right, Keely. We could have brought this down. Look in your book and how the answer wants it. This might be because it's not just a number. You know what I mean? It's not just like -2 or -3. It's got like x's attached with it.
And if it was
same
like,
thing here. You know what? I think that's probably
so if it was,
like let me just do. So I matched them up with like what was in your book, and like they left this one like this, but I think it's because it's an x, not just a number. That would probably make
and if it
sense
was
why.
negative, that whole thing would just go, if it was -5x right there, it'd just be e over 5x.
Yeah, the 5x on the bottom though. Good question. All right, last one, and then.
Those hurt?
Kosher roll. You could try kosher roll. It's an easy way, but you won't think of it.
Well, why don't you simplify it?
Now, You agree to second that motion?
I third that motion.
Okay,
Where was
I
it?
know,
Okay, now, sometimes you guys do have to use, because we just did a product rule, you might have to use a quotient rule, but don't forget about all the stuff you guys have done this chapter with ln. Think about your natural log property.
Love natural.
Yeah, use your property. So really, this is like saying ln of 1 plus e to the x. Then what? Minus. Yeah, good job. Okay. Right. So, yeah, you do that. Right. Now this, just to kind of refresh the memory, because I know it's been quite a while here. When you guys did your derivative, EDF of ln u, there was your rule. Does anybody remember the rule for this?
Absolutely.
Because you guys are integrating.
ln cancel the EL.
Yes, Matt got it. You prime over u. Oh, you did, Kelly. I'm sorry. Good job.
I just can't keep that one.
All right, or du over u. Okay. So keep this in mind here. So when you guys are working with this part, right? When you guys are taking your u is this whole thing. So imagine we want du over u. What's going to be the derivative of this? E to the x. So this one's going to become e to the x over your u, which is 1 plus e to the x. Okay. Oh gosh. I break my jewelry every day in this class. I don't know what happened. Alright. Now this is a little bit trickier. What's going to be your derivative here? Negative e to the x. Good job. Over 1 minus e to the x. It's going to be your u. Good. Now,
we can eat the bottoms.
okay, we can do that. Now, what about the bottoms though?
They're opposites of each other, so one of them just going to be a negative one. Isn't that like a roll back?
Oh, yeah. It's reverse with subtraction. You can do that though.
Yeah.
Yeah. Yeah, we can't do it here though, because if you let's say if you multiply this by -1, you would have a -1 plus e to the x, and you don't have a -1 over here. If they were reverse with subtraction on the bottom, you could do that though. I'm sorry. So we really have to get a common denominator.
I thought I had it.
Oh, I know.
But that was good, right?
That was good. That's great. I'm impressed you remembered that.
No. That's not in my body.
Right, so distribute this thing too. How would you represent e to the x times e to the x? Yeah, good job. Yeah. That was great. No, that was perfect. E to the x squared. Good job. Okay. Now same thing over here.
E to the x squared to the x to the e squared. Yeah.
So e to the x times 1 is e to the x. Especially with this stuff, it's like tons of e's.
I can't write e to the x. I keep writing x to the x. Keep writing the x.
Okay. And then just make sure at the end you reduce things, cancel stuff out. Those are gone. Those are gone. Yeah, of course. Good job. 2d back. Yeah. You polar? Yeah, if you wanted to FOIL it out, you could.
Definitely take an e to the x and cross it out on the top and the bottom.
We won't be able to do that though because
They're married.
you're married by admission. You have like part of a sum or.
Alright, well, I feel like I'm drunk right now, so that's my excuse.
Okay, that's all I got for you guys today. You did awesome. No homework? No, sorry.
It's okay. It's your responsibility to get us home.
Thanks, Ryan.
Ryan, you do homework.
Actually, it's Mega down.
Sorry.
Mega went down.
39. Good job.
Super.